Thanks everybody for March Data Stewardship Committee telecom. And today, after a quick updates for ESIP and the Data Stewardship Committee related activities, we will have a invited presentation by Zach and Rebecca, followed by the Q&As and discussion on selecting a common reference metadata schema. So if you could, I have the link in the chat. If you could put your attendance at the top, the name only. But if you're first time or you have not done so, you could add your information during the call or after to the participant table here. If you click that, will take you to the table. So we start with ESIP updates. Alicia, would you like to mention a couple things? I did do two here. If you have more, feel free to add.
Yeah, I just wanted to let everyone know that the Raskin Scholarship applications are currently open until March 13th. So if you know of a graduate student that you think would be really deserving of this scholarship, please do share this information with them. And Panga's also added to the notes document there that the recordings from the January meeting are now available on our YouTube channel. I'll share the link to that here in a second and add that to the notes document. And then because all of you are here, you know that ESIP now has a new registration process for our meetings. So now when you register for the entire series for the rest of the year. We're hoping that reduces barriers for folks to join meetings moving forward. But if you have any questions or feedback, hopefully this is working better for everyone, but we still want to make sure we're continuing to improve the process for all of you. So please do let us know if you're having any challenges with this new process. So thanks.
Thank you. It has been pretty straightforward for me. Hopefully, nobody has run into issue today, and do let us know if you do. So for the Data Stewardship Committee part of the first report, initial findings on the persist identifiers and reg metadata is out. I have the link there if you're interested in look at it and also participate or share feedback with me, please feel free to do so. And I have already received a couple excellent feedback from Matt, who's been leading NS. I'm sorry, NS funded project on the persist identifier on instrument. He has indicated share some insights, and I linked here, and we will include those if we have a follow-on report to, we already have several ideas. We want to go deeper into more varieties, but if we get to that part. And he also shared that a EU group, I have put the link here, started to register and publish a scientific instrument. So that's another useful resources if of interest to us. And I had a very good conversation with Chris Ardman and about adopting the READ and occurred. So he's part of READ project, and he's participated in the project for US pilot as well. So ESIP has participated in that pilot as one of the focal point. Alicia, are you the focal point, or Aaron is the focal point POC for the READ US pilot?
It's me. I'm the point of contact for
Okay,
ESIP.
great,
Yeah.
great. So we're working through the workflows they are established. Unfortunately, they won't be ready to issue one until maybe later this year. So Chris was thinking, working, perhaps he can work with an ARDC to see whether, potentially to issue one for Data Stewardship Committee. What I would like to do is to include it in the like Augur ID for people and use that read ID for DSC and why put out the reports and the ID would link everything together. Any other updates that anyone would like to share? Please feel free to unmute yourself. Okay. We move on to the next agenda. We have an invited presentation today by Zach and Rebecca. And last telecom, we started to looking at the crosswalk of the EU 15 metadata schemas to schema.org. We have started to discuss what are the ones we can select as a common reference metadata schema. Schema.org and the DataCite has came out as the two strong candidates. And when I was looking through some of the literatures, I found a presentation by the group, and I reached out to Rebecca and Zach, and I truly appreciate they have accepted my invitation, and they are here to present their work. Both of them are coming from NASA's Heliophysics Digital Resources Library, and that works on updating heliophysics metadata and among others. And Rebecca is your principal open science scientist. Yeah, she is a principal open science scientist, and she is responsible for developing and recommending strategy in area open and gold strategy science, policy compliance, community support, and other relevant areas. I have worked with Rebecca in the past, and first time to to see Zach. So I'm looking forward to their talk titled Improving and Assessing FAIR for HDRL metadata mapping to schema.org and the dataset. So their talk would set the stage for our discussion, and we will have a more in-depth discussion on the debating which one will be good for us to use. So, Rebecca, I think Zach, you're going to go first. Take away, and I am going to stop sharing my screen.
All right. Everyone can see it. We're good?
Yes.
All right. So hello, everyone. I'm Zach Boquet. I'll be co-presenting this with Rebecca Ringuette. We're both from NASA Heliophysics Digital Resource Library. We're talking about improving and assessing FAIR for our metadata, specifically mapping to schema.org and DataCite. As far as our motivation for this effort goes, it's mainly revolving around NASA Science Mission Directorate's focus on open science, including FAIR for data. And those pillars of open science are on the right there. So that second one, open available science, is of particular note since it pertains to FAIR, with FAIR standing for findable, accessible, interoperable, and reusable. Secondly, we wanted to improve our compliance with NASA policies. And lastly, we were looking for easy improvements in FAIR that are also reportable. Some benefits for NASA HDRL. So improving the mapping from SPACE, which is our heliophysics specific metadata model. It's an international standard as well, to both DataCite and schema.org, improve several things. So firstly, our FAIR score for our resources as assessed by existing tools like the Fuji tool, which is at the top right, and DataCite analysis tools like the one at the bottom right. Secondly, it improves our interoperability with other sciences, such as ocean sciences. And lastly, of course, it improves our richness and discoverability in external systems. And it's important to note that all this is possible without adding much metadata. And another big thing that's not listed here is that we want to improve the actual pipeline, the actual software itself, because just adding rich metadata won't be worth it if the underlying pipeline doesn't actually work as intended. So the big goal here was to have everything synchronized. So now diving right into the metadata here. So what you see on the left is the previously embedded schema.org JSON LD and the space landing page. So this is specifically for the gold standard space record we chose as a group. And this is just a well-populated space record. And it's linked to the top right as well. We'll share the slides later. But after analyzing this in terms of the expertise from the group, as well as against Google's guidelines for dataset metadata, we found a few issues with how it currently is listed out here. So for one, the citation should not be included in the metadata here. The authors are one large giant string instead of being properly split out. The keywords are incorrectly listed in genre property. The license that's found here is incorrect. There is no space landing page URL included here. And lastly, there's metadata that's not found anywhere in the space record in here, which is just bad practice. And just to show you all that this incorrect metadata is affecting us, this is a screenshot from Google's dataset search. So this is the same gold standard space record you just saw the metadata for. And you can see in that red box there that incorrect single string of authors and incorrect license is there. So this is affecting us, and we definitely needed to improve it. Now, as far as the DataCite metadata goes, well, firstly, on the left is that same schema.org metadata, and on the right is the DataCite metadata. And both of these are based on that same gold standard space record. So ideally, the metadata between these two should be very similar. They shouldn't have any mismatches, but that wasn't the case. So for example, the authors on the DataCite side were properly split out, so not in that giant single string, but it does so while adding RORs, which are not from the space record. The license that's listed in DataCite here is different from what is found in schema.org. But it's also still incorrect, and it's not found in the space record. And then lastly, the keywords on DataCite side, those are properly listed there. But as we know for the schema.org side, that's incorrect. And so an important thing to note as well, all these mismatches happened because our processes were not synchronized, as I mentioned before, and were highly manual. And so that was another effort for this project, was to resolve that. So now moving right into the mapping and implementation of this, we first began with the existing external standards. So this is the guidelines for mapping from scientific data sets to schema.org metadata, and that was provided to us by ESIP's very own Science on Schema.org group. And then we also began with the existing Research Data Alliance mapping as well. We then formed an informal working group, which had international participation for the schema.org effort, and then collaborated with that same Science on Schema.org community for additional input. And we also got input from some internal Helio-specific groups. Once that mapping was then agreed upon and finalized, we implemented it within Python following best practices and incorporated those mappings into existing open source software for the schema.org side and new open source software for the DataCite side. And that that package that's linked there, that SOSO package, is developed by Issa Superior and Colin Smith. And lastly, this process was the same for both of these mapping efforts. Now, this slide, it's kind of summarized in the chart here on the right. You really only need to focus on those green bars here. But this is covering that metadata that did have to change to improve our FAIR scores. So I mentioned it earlier, all those benefits without adding much metadata. This is the metadata we did add. And so just to summarize, we added over 2,200 dataset licenses, updated over 1,800 publisher names, and added around 600 publishers. So this is also, a little caveat. This also helped with improving at least our DataCite FAIR score. But as far as shifting all this into operations, we can start off with DataCite. So once this improved mapping was implemented, a non-technical person was trained in this new workflow. And then we iterated on this workflow to improve it, so to fix bugs and whatnot. And we're currently up to around 50 DOI updates and creations per batch, although we're aiming for 2,000 plus. And at this point, I'd like to kind of direct your attention to this chart on the right, which summarizes the amount of DOIs we've created over the past few years. And notice that vertical bar on the far ends is whenever the far right side is whenever we implemented the improved DataCite mapping. So this was around November of last year, so quite recently. And as you can see on that chart, since that point, that one non-technical person has made 641 DOIs. And that's more than 2023, and that's more than some of these years combined. So we're really happy with that. Excuse me. And another important thing to note, so all of those previous years, this was done by multiple people. And as I mentioned, this is just one person. And also during the same time, they were able to update all 2,200 DataCite records that we have with that new improved metadata. So the benefits are twofold here. But moving on to schema.org, so that metadata, as I mentioned, is embedded in the SPACE landing pages, and those are automatically generated and updated hourly. And that old incorrect metadata was generated by hard-coded XSLT code, which is just XML-specific code. And so that is now being overridden by the metadata generated by that SOSO package, which we can now move on to the results. So these results are pretty perfectly summarized in this chart here on the right. So just to kind of guide you through this, this blue line here is the average FAIR score for all DataCite repositories. The red line is how we HDRL were doing before the mapping, and the yellow line is how we were doing after the mapping. And so that DataCite average is at 23%. We were only a little bit better at 24%. But now after the mapping, we are now at 37%. So this is a 13% boost. We're pretty happy with that. And we are planning to have some minor updates to bump up that air contact score. But any further increases will require a complete metadata system redesign, and that'll be coming in the future soon with SPACE 2.0. Moving right along to the schema.org results. These are screenshots of the Fuji tool I mentioned earlier. This is a summary of the FAIR score for that same gold standard SPACE record. So on the left is the results from before the mapping. And so you'll see there was a score of 58%. And on the right, after the new mapping, you can see now that we've jumped up almost 30%. And so it's at 87% FAIR score there. and we're really excited about this. Just also an aside here, if anyone is at all associated with the Fuji tool, it would be great if there was an API, but anyways, moving on here. So before I hand it off to Rebecca, just wanted to highlight that these new mappings now have normalized the metadata. So those issues I mentioned before with the mismatch with schema.org and DataCite metadata is now resolved. So for example, on the left, so this is on the left is the new schema.org metadata. On the right is the new DataCite metadata. And as you can see, the authors on schema.org side are now properly split out, unlike before, which is matching with what is found in DataCite. So with that, I'd like to go ahead and hand it off to Rebecca.
Thanks, Zach, if you wouldn't mind driving.
Yeah.
Great. All right, so now I want to bring this here to the topic this group is considering about whether to prioritize DataCite or schema.org as this intersection point between the different domain-specific metadata areas you have in earth science. We also had the same challenge in heliophysics too. So as Zach outlined before, we started with this mapping to schema.org, and it was really cool with the mapping because we had Baptiste Coney on our team, and he was part of that original effort in the RDA mapping development. As I put in the chat, he was very happy to update that work. So that was super cool. But when we were nearing completion of this mapping from space to schema.org, we discovered this DataCite API capability to take that schema.org JSON all day and just pipe it into DataCite. We were like, this is super awesome. We only have to do one mapping. Let's do this and go. But we were quite disappointed with the results there. There were a long list of metadata fields that simply were not accepted. So one thing to note is that when we did the mapping to schema.org, we didn't just do it in whatever we thought was reasonable. We did it in alignment with that ESIP's Science on Schema.org's requirements to represent those data sets on schema.org. So we can be interoperable across the scientists and how we represent our data sets in that metadata. So we were expecting much better results than what we got from the DataCite API conversion service. The number of fields that weren't mapped at all were troubling. So we, after a little back and forth with the customer service department, if you will, with that part of DataCite, it didn't go anywhere. So we decided that we had to have a separate mapping from space to DataCite supported by a separate software implementation to really get the results that we need. Next, please. All right, so we did that, and that was huge advances on accelerating our operations, increasing our richness. Sorry, but then we decided to go back and test. Well, what happens if we do this in reverse? We want to know what schema.org metadata people would get from DataCite's API for our data sets. What is this going to look like? And again, it was pretty disappointing. So there were many metadata fields that aren't even mapped within that from DataCite schema to schema.org. It's just dropped completely. So there's significant information loss. There's also other problems. So contributors are mapped as editors in schema.org, which was surprising because that's not the case in real life at all. And also they have this field that they came up with called contributor type that they add on to their schema.org output, which doesn't validate. That's not actually a field in schema.org. So maybe that predates the current implementation in schema.org of what fields they have. I don't know. But we definitely don't want schema.org metadata from DataCite's API that won't validate and then will cause indexing problems. So further justifying our initial efforts to map to schema.org separately. Kind of a pet peeve of mine, I threw it in the slides, is that all the work that we did to make sure people are using terms from controlled vocabularies that we've developed and that others have developed, and then putting that information in to support those terms, that all gets lost when mapping from DataCite to schema.org. And there's other problems going in reverse that I might get to later. But, there were some problems we discovered with the conversions in DataCite's API between DataCite and schema.org, just both ways. So next slide, please. But there is hope. So we brought these challenges to DataCite through an opportunity, surprisingly through the Research Software Alliance, because the challenges in DataCite's API mapping for this metadata is the same for software, if not worse. So DataCite happily received the feedback along with some other things that need to be worked on, but they're happy to iterate with us. So like, sweet, this is going to be awesome, right? But they're happy to iterate with us on a new mapping to be implemented into their API for data sets and software. If that's interesting to you, let me know. So I took the two mappings that we had from space to these systems, merged them together, made them more full, and now we have a draft mapping from DataCite to schema.org, open for public contribution, public work, and we're getting some momentum behind this. So this effort particularly lives under the ESIP Sciential Schema.org group. It's hosted on their GitHub. They're going to be supporting us with some meeting time to work on this. Particularly in April, we're going to have a 2-hour session. So please jump on if this is interesting or useful to you. We really need all the feedback and contribution we can. We want this to be as accurate as possible because everyone's going to benefit from this. And if we get it wrong, it's going to stink for everybody. So please jump on. Let's make sure this is reasonably correct. And once we get this settled with DataCite, we'll work on the reverse mapping too. Next, please. All right, let's bring this home though. So the original question is, what should we prioritize for mapping? Should we map to DataCite or should everyone map to schema.org? And the thing I'd like to bring to this conversation is a comparison of purposes and of capabilities between the two systems. So this table here hopes to summarize at least some high-level points. So on the DataCite side, with discussions with different publishers relevant to heliophysics, such as AGU, AAS, Elsevier, these kinds of groups, they consider the DataCite metadata as the metadata of record. And there's a bunch of services tied to that that funders use and institutions use to track their impact, to track their productivity, to have interlinking between different types of resources. There are some issues with that that CopDesk is working on that we're supporting. And then, of course, for citation generation, right, through those services connected to the DOIs. So there's a lot of purpose and tracking built into the DataCite system. And if you look at schema.org, their big purpose there is for discovery. Not citation tracking, not interlinking, it's discovery. Likely including by AI tools, although no AI developer of those tools is telling us one way or another, so we're just guessing. So different purposes there, but also different services. So DataCite, once we fix all the conversions in there, at least between the two systems, they have metadata conversion capabilities that are going to be reasonably rich. Of course, information loss is unavoidable, even inside the DataCite API conversions. But there are conversion services attached, so there's at least some reasonable stuff you could pull out without having to draft both mappings if you really don't want to. But with schema.org, they have much more flexibility in their system than DataCite does, and maybe correctly so, thankfully. But there's no metadata conversion support that they offer that lives on the DataCite side of things. Okay, so less information lost when converting to schema.org in a custom pathway if that's what you choose. There's also different scopes here and different conventions. So DataCite is, from my perspective, the de facto standard really for dataset DOIs. It's used internationally. Numbers of these things are super high. Same thing for software too. On the schema.org side of things, DCAT is still considered a very strong but compatible competitor, right? There are ways to make these things work together and still validate. So, Zach, could you click the hide button so people can see the little conclusion there? Great, thank you. So for heliophysics, what we've decided for near term, at minimum until those metadata conversion capabilities are updated in the API, that we've decided that we must prioritize both. To be honest, the lacking capability is why we actually have these mappings from space into both systems already implemented and now in operations. But of course, these things require maintenance into the future. But even after those metadata conversions are updated in DataCite's API, we're likely going to continue maintaining these things and updating the mappings as time goes on because we want to maximize our flexibility between the systems, particularly for having, for example, terms in our schema.org that aren't in keywords but sourced from vocabularies. There's no structure in DataCite for that yet. Maybe in 4.0, sorry, 5.0. They're on 4.6 or 4.7 right now. So we're planning to prioritize mapping to both systems for the as far as we can see into the future. Next slide, please. Great, let's bring it home here. So Zach and I have presented to you our efforts mapping from SPACE to both DataCite and schema.org. And we did this so that we could improve the richness of our metadata and get a lot of more return on investment for the work that our curators have been spending so much time on. This has increased our FAIR scores on both sides. This has increased our interoperability with other scientists, such as Ocean Sciences with Otis. We're now getting more discoverability through our landing pages with that embedded metadata, and we've accelerated our operations associated with DOIs. We're planning to add instruments and observatories to these processes, and we're playing with the idea of building a tool to assess FAIR on the heliophysics specific metadata side, to gamify metadata creation and all these kinds of fun ideas. But happy to answer questions and contribute to the discussion from here, both Zach and I. So that's it. Thank you.
Thank you so much. That's excellent presentation. And it's very relevant to what we're going to discuss. So I'm going to leave 5 minutes or so for people to, if you have a question, yes. Please either raise your hand or unmute yourself. So Rebecca and Zach, oh, actually, I do see hands.
They had to think a second.
Yeah, I'm sorry, I don't see which one is first. I'm just going to look at it. Jonathan, go ahead.
Okay. Sorry, I didn't see the other hand. But yeah, Rebecca, this is I've heard about this work for a while, and this is a good summary, so thanks for presenting it. One thing I did do when I got the the link to the presentation, I went to I think this is the space page, and I just had a clarification. Is this page showing the updated metadata? And for example, like the authors, I only see them as a list, like a comma separated value list. I don't see them broken out individually. So I assume that's happening kind of behind the scenes.
So the landing page sitting behind the DOI?
Yeah.
Okay. So that is also another pet peeve, but that problem lies on the space side. The metadata that we're talking about is embedded into that page. So I don't know what kind of browser that you have,
I have
but
to open the schema.org.
Yeah, you have to look in the software developer tools to actually see what that metadata is.
Okay.
In your browser.
Yeah, and I was wondering, can we see the old one for side-by-side comparison? Maybe you could
We have
send us.
screenshots. Actually, I have a folder. Well, Zach, you have the folder to the old stuff. It's pretty bad. That's why we took screenshots before. Yeah,
Okay.
the web
That's
browsers
good
don't.
enough.
Yeah, they don't let you see before and after. It's just the new stuff. Zach, are you comfortable with sharing those directories in the chat, perhaps, or the notes?
Yeah, I can share the we have a Google folder of all the old schema.org metadata. I can share that.
It's
Yeah,
bad.
and
That's why we replaced it, guys.
the other just off the cuff observation is most of the metadata is about the parameters. And I don't think that even enters this conversation. I think that's not considered discovery metadata. Is that right?
So again, you're looking at space. What Zach was hinting at is that we are in the process of completely redesigning space. This is a 20-year-old system that's never been significantly updated. Its original purpose was to, let's see if I get the acronym right, archive, search, and extract. We're removing extract. So a lot of that parameter metadata is going to collapse into something more reasonable. And we don't map all of that into DataCite or schema.org at all. It's just, we agreed that's not relevant. So we agree with you.
Okay, thank you.
Thank
Sure.
you for the question. Sean, go ahead.
Yeah, hi both of you, Zach and Rebecca.
Yep.
Great presentation.
Thank you.
You might have already answered this question, but I was, I work in the ocean sciences space, and I've been looking at schema.org a little bit more as something that we should support. We currently don't support it, and instead opt to use DataCite in combination with various ISO profiles. I believe it's ISO 19115. But my question was getting into the nitty gritty of looking into the details of Science on Schema.org's recommendations. There, you can have like really high level metadata, and then more verbose, like hyper specific things such as potential action, search action, things that help you indicate, like maybe this is what the previous commentator was saying, but parameters for specific searches in API related queries to actually pull up exact data of a data set. So I was wondering if that was something you've looked into as well.
Absolutely. Zach, go for it.
Yeah. So yeah, we have made use of that potential actions field in schema.org. And probably in most of the space records that we have, it's used because I think only like 10 to 12 links in all of the 3,000 plus space records are actual direct links to the data. They're all mostly links to services. And so that potential actions is used very, very prevalently in that new updated metadata. I can show if y'all would like, I can show this gold standard space record and like the developer tools right now if y'all want, and I can show like what it looks like. Or if you'd rather just me send a link, that's fine too.
I don't want to derail the conversation, but I would certainly be interested in whatever format that takes.
Okay, well, what do you prefer?
I know the other person who asked about the embedded metadata. So there's no more like if we're fine moving on like from the slides, I can have the background be that new metadata if we want.
Not hearing objections. Go for it.
All right. Just pull it up here.
You might have to make your text size a little bigger.
That's true. Yeah.
So there's our terrible landing page. Topic for another day.
Yeah, and so opening the developer tools and the HTML head here, there's this script type, and that's where this new and improved metadata is found here. So if we can, let's see, I'll scroll down to the potential actions for you. Here we go. So it's a little bit hard to see in this kind of interface, but yeah, there's multiple links in this landing page, which we can put in this potential actions. So there's plenty of examples here if you'd like to look at this.
Do you mind just plotting that example, just like plopping that in the comments, so maybe we could share it in the notes.
I know we probably would get into implementation detail later, and for this call, I actually would like to focus on a little bit high level. And I think one thing it's important is for what purpose Are we, as far as the Data Stewardship Committee mapping is concerned, are we focusing on discovery or are we focusing on returning rich metadata? It seems to be there's possibility trying to have those overlap a little bit. But I do have one question to you, Rebecca and Zach. When you see mapping to schema.org or DataCite, the quality of metadata, are you improving your quality metadata on, the metadata on sparse, or you're improving the metadata that's displaced or collected by schema.org or by DataCite? It wasn't
So,
very clear to me.
sure. Let me take this one, Zach. So one of the problems that we had before that Zach described is that some of the metadata that was being added to DataCite and schema.org with these previously manual processes were not in space. So someone was coming in alongside and just throwing some stuff in. Like, that's not okay. Our curators need to review this. This has to be 5-star quality stuff. We're a NASA Science Data Repository. We demand high standards. So what we're talking about is not only an automated system so that when metadata corrections come in our SPACE records, that gets automatically pipelined out. This also removes any, like anyone actually running the software, they don't get to make changes to the metadata. Those are not the correct people to make those changes, and from our perspective in heliophysics, that's what our curators need to be doing. And any changes from now on happen in the SPACE records so that there's no desynchronization, no denormalization between the systems. People get the correct metadata. So in addition to fixing that problem, we added a lot more terms. So if you yep, the screenshot right here. So the screenshot on the left is just about the entirety of that embedded schema.org metadata before our work. As you just saw Zach scrolling through, our new metadata is pages longer. So that's the increase in richness and accuracy. Does that help?
Okay. Yeah, that's very helpful.
Okay.
Okay. Any other questions for Rebecca and Zach before I move on to discussion? Well, we've been discussing, but I think I want to kind of provide a little bit of context before we have a more in-depth discussion in 10 minutes. Okay, so let me share my screen. Thank you very much. If you stop sharing.
Thanks for the opportunity.
Yeah, thank you so much.
Oh, it's pleasure's all ours. And you're not done yet. So we'll
I'm here, all ears.
Yep.
Brand engaged. I have had
okay,
my coffee.
great. Stay put. So I am going to show my screen. So for this particular discussion, is really we wanted to identify a common reference schema. So the reason for that is we wanted to have the machine readable crosswalks among schemas, but it's not very efficient if we do among themselves. So our alternative option will be to select a common reference and we are all crosswalk to that particular one. So before we get to, is it DataCite or schema, we can see that even just for the selection we have collected so far, main, it's 6 of them, and we're expecting to have more. And there's a difference between 15 or 6. And also if we do among themselves and any one schema changes, we have to update all of them. And I don't think we have a capacity to do that. So it makes sense to have identify a common reference schema to do that. And in this table, I have pulled out some basic characteristic for both, and you can take a look at it. I think I don't need to go over them because I think Rebecca has done excellent job to summarize the basic thing between these two here. And the next table, I recap the comments that has been entered by the working group and also by some of the people from other collaborative areas. So the one thing is about the schema.org is for discovery and also widely accepted by the search agent callers, and it's flexible and easy to implement. It's flexible, easy to implement if we use SSO profiles. But on the other hand, the DOI is being, DataCite is being extended use. Everybody, when they obtain DOI for their dataset, they have to go through obtain the DOI for their dataset. They have to go through the dataset metadata, and they seems to be more willingly to work with individual projects for earth science need. As Rebecca has indicated, they were able to work with them, and that they have worked. Like Ted has been working with them, and it's part of the board to improve the metadata. So from that perspective, it kind of there's an advantage for it. And the fact we are doing this for rich metadata. So we would like to return the core recommended fields that considered to be rich metadata. From that perspective, data set does have advantage. But the schema.org sort of become a more international option for people to adapt to. So they both, I think either one of them would be good with some caveats. So I like to open the floor for more comments and feedback. And also, if somebody would like to recommend someone else, also a time to do so. Rebecca.
So I already said the heliophysics standpoint, but the once that API service from DataCite gets corrected with the new mappings, then it becomes like the choice between the two, well, the gap between the two rather decreases, because then if you choose one, you can map into the other. Now, the challenge you'll probably want to consider is how good is that mapping? Um, so participate.
Yeah.
But anyway.
So that's good comment, Rebecca. I want to point out that this mapping is not for the completeness of metadata records. This mapping is really saying if I were to use it, let's say NASA, CMMR, UMMC, and those are the basic fields, and this is how the fields crosswalk to that common reference schema. So the machines, once they have the profile, they can understand how they relate it to more for naming convention rather than completeness of all the data collections, all the data metadata records that NASA hosts. Is that helpful?
Oh, I was just saying if you have to choose one,
Yeah,
then you get increased interoperability later with the other without having to write a second mapping.
I got you. Okay, that's good to know. Yeah, thank you. Xiang, go ahead.
Yeah, sure. Can you hear me? So I haven't been, involved with this very long. I've actually been coming to the DSC meetings for a couple meetings now. But just looking at that summary table you have there, it looks to me like these two schemas actually have very different purposes.
Yes.
And I think the question the DSC actually has to ask is, what are you trying to do? You know, what exactly is this reference schema you're trying to decide on supposed to do? Because I look at that graphic that you had that shows this reference schema in between a bunch of data centers. Okay. And that immediately tells me that the purpose of this is to support discovery across multiple data centers. You want to be able to allow somebody to, find stuff across all these different data centers, which I guess leans more toward the one system that supports discovery more than the one that supports publishers and citation. That's just my thoughts.
That's one part. Yeah. So the purpose of this work is really to improve the interoperability, rich
Mhm.
metadata across systems. So, Jonathan.
Yeah, thanks. This is I'm still trying to understand the need here. So um in a previous, maybe 10 years ago, there was a system to do this following ISO geospatial metadata 19115 or 113, whatever. I can't remember the numbers now because it's been 10
Still
years.
115-2.
And actually, I think like you look at some of these repositories, NASA and NOAA, they're already both using the CMR. So they're both all actively addressing this challenge with using a common metadata format and repository. Although, from what I've heard, it has taken some time for NOAA to take it up and actually start using it effectively. So there's a lot of organizational investment in building the community-based tool. But now that they've done it, I I don't understand why we can't leverage those past efforts for federated metadata. And why are we kind of rethinking this?
Yeah, that's a ideal case. However, it takes a lot of effort and time. It's even for NOAA case, it takes them years to integrate CMR metadata standards, and it still does not work as well as they would like to. So the idea here is provide that feedback to capture the naming conventions variations among different organizations, rather than force one organization to, all the organizations to use the same standards. And personally, I think that would never happen because there are always nuances and different requirements for individual metadata, individual organizations to capture their data. So it's almost like for, if we tell Rebecca, it's like, okay, why can't you use the CMR schema rather than using your own? Yeah, it's very challenge up uphill battle to do. And so from that perspective, when we look at the metadata that's captured in this particular workbook, even same ISO implementation can be different, and a lot of them are really the naming conventions. And I think that's a lot easier to tell machine by having the profile. It's a lot easier to develop rather than having the DSC as this like sort of working group to tell organization you shall do this, you shall do that, or spend we don't have the capacity or effort to do that either. Hope that helps. So we come to the top of the hour, and I am going to go back to Skimmer. And I want to thank Rebecca and Zach again for the excellent talk and for the recap of their work and also share their perspectives. And it's, if I have to say, for the rich metadata, so I'm really 50-50 because I do understand for the discovery and it's like very simple, very lean set. Schema.org is one way to go. For capture the richness in the data set, it's one to go. However, it's good to hear from Rebecca that it sounds like if we go with one and later on the work conversion, it won't be too bad. Is that fair statement, Rebecca?
Just about.
So we can just pick one. We won't be too far off. And I think one thing is that we can pick one, start working on it, but we also do one crosswalk between schema.org and the DataCite. And that way, with that set, we should be able to accomplish what we are doing, we're set out to do. So I wanted to.
Can I ask just one more quick question?
Sure.
Have you worked with the cross-domain interoperability framework? As it seems like they're currently addressing that same challenge.
I have been following their work from very beginning, and I think they started with they have this developed their own framework, and that also got adapted with various system. But they seems to come to conclusion they're going to use converging to schema.org, if my understanding is correct. And so the one of the main drawback using schema.org is a lot of the earth science metadata fields won't be there, but that may not be the case anymore. Maybe Google search, Earth data search has already addressed them. I'm not, I haven't really keep up with that in that particular aspect.
Okay, that's helpful. Thank you.
Yeah.
Sorry to interrupt, Ping. I just wanted to let y'all know there's another meeting happening in this room.
Oh, okay. So we need to go.
Sorry to make you rush.
Yeah, if I can get the chat later on, that would be great. And
Yeah.
again, I want to thank everybody, and especially Rebecca and Zach, and also remind you that if you have not done so, add your information to the participate table. And our next meeting is April 13, and we're going to look at it how to make a vocabulary fair. Bye, everybody. Thanks again.
Hi,
Thanks,
thank you.
everyone.
Thanks so much.